Boom! SpaceX's massive Starship just exploded again. But here's what NASA can't believe. There's absolutely no way out. No escape pods. No emergency rockets. Nothing. Every other spacecraft, they've got multiple escape systems. Apollo had escape towers. Soyuz has abort rockets. Even SpaceX's own Dragon can blast away from danger in seconds. But Starship passengers, they're completely trapped. And Elon Musk did this on purpose. His reasoning is so insane, so brilliant, that it's turning 60 years of space safety upside down. The engineering behind this decision will shock you, and the real reason might save more lives than any escape system ever could. Let's dive right in. So what exactly is an escape system? You're strapped inside a rocket, engines roaring beneath you, when suddenly, boom, the entire vehicle starts tearing itself apart. In that split second, you have maybe 3 seconds before you're vaporized. Traditional spacecraft fire escape rockets that blast you away at over 10 Gs. It's like being hit by a freight train for 5 agonizing seconds. But you survive to tell the story. Every major spacecraft has one. Apollo's escape tower could yank astronauts to safety in under 2 seconds. The Soyuz has actually saved lives 3 times in real missions. Even SpaceX's own Crew Dragon packs 8 Super Draco engines, each one generating 71,000 pounds of thrust. But Starship? Absolutely nothing. When that explosion happens, passengers are completely trapped. No way out. No second chance. This isn't just controversial. It's downright terrifying. Here's where Musk's decision becomes truly insane. Traditional escape towers work on small capsules weighing maybe 10 tons. Starship weighs 1,200 tons when fully loaded. That's not just big. That's like trying to save a falling skyscraper with a bottle rocket. Could they use integrated thrusters like Crew Dragon? The math is brutal. Crew Dragon's 8 engines can accelerate 6 tons at lightning speed. To give Starship the same escape performance, you'd need 160 Super Draco engines. The weight alone would destroy any chance of reaching orbit. The fuel tanks for those engines? They take up half the ship. The complexity? Mind-boggling. The cost? Astronomical. But even if they somehow solved all that, there's an even darker problem lurking beneath the surface. Most escape systems use solid rockets for one terrifying reason. They ignite instantly. Think of a firecracker. Light the fuse. Bang! No delay, no hesitation. Pure, immediate violence. Liquid engines? They're like trying to start a frozen car in a blizzard during an emergency. Starship's Raptor engines need precious seconds to spin up, pressurize, and reach full thrust. In an explosion scenario, you don't have seconds, you have milliseconds. But wait, doesn't Crew Dragon use liquid fuel? Here's the engineering secret NASA doesn't advertise. Super Draco engines are pressure-fed systems. They're basically controlled bombs sitting under pressure, ready to explode on command. Starship's Raptors? They're incredibly complex turbopump systems, beautiful engineering, but they need time to wake up and get angry. Time you simply don't have when the rocket beneath you is disintegrating. The irony is crushing. SpaceX built the most advanced rocket engines in history, but in an emergency, they're too sophisticated to save you. Even if Starship had a perfect escape system, here's the brutal truth most people never consider. It would only work in a tiny, narrow window of opportunity. Too low. You hit the ground before your parachutes even have time to deploy. Your escape pod becomes a high-speed crater maker. Too high? You're in the vacuum of space. No air to breathe, no atmosphere for parachutes, just the cold, endless void. The space shuttle had a bailout system, but it only worked at exactly 60,000 feet. Astronauts literally had to jump out of the orbiter and parachute into the ocean like action movie heroes, one by one, leaping into 230 miles per hour winds, hoping their parachutes would save them. Above that altitude, you're dead. Below it, also dead. But here's what makes Starship different and infinitely more terrifying. Starship missions don't just go to low Earth orbit. They go to Mars. That's 140 million miles away. a 9-month journey through the deadliest environment known to humanity. At what point during that epic voyage would an escape pod even help you? Mile marker, 50 million? Day 180 of the journey? You can't exactly call an Uber in deep space. Here's what NASA doesn't want you to know, what they'd rather keep buried in dusty mission reports. In 60 years of spaceflight, escape systems have only been used 3 times. 3. That's it. And one of those times, it actually killed someone. Let me tell you that story, because it reveals everything wrong with our obsession with escape systems. Soviet Union. A Soyuz rocket sits on the launch pad, looking perfectly normal. The escape system suddenly fires, completely by accident. The capsule shoots into the sky like a cannonball. But here's the nightmare part. The escaped capsule's exhaust ignited the rocket's remaining fuel. The explosion was so massive it killed a launch technician on the ground and destroyed the entire launch pad for 7 months. The escape system, designed to save lives, became a murder weapon. Another Soyuz mission. This time, the escape system fired just 6 seconds before a massive explosion consumed the launch pad. It saved 2 lives. But was it really worth decades of added complexity, weight, and cost for every other mission? The most recent use was 2018. A Soyuz booster failed in flight. The crew survived, but endured 6 to 7 Gs of bone-crushing force and landed in the middle of frozen nowhere in Kazakhstan. 3 saves in 60 years, against thousands of successful launches without needing any escape system at all. So why do we obsess over them? This is where Musk's thinking becomes either genius or completely insane. His logic? Make the rocket so reliable that you never need an escape system. Think about it. Commercial airlines don't have ejection seats. Cars don't have escape pods. Trains don't have emergency helicopters hovering overhead. Instead, we make them incredibly safe through relentless testing, redundancy, and millions of hours of real-world experience. But here's where it gets controversial. Traditional space agencies have spent 60 years perfecting escape systems for rockets they'd fly once and throw away. Single-use death machines with single-use safety systems. What if that entire approach is backwards? What if the real safety comes from flying the same rocket hundreds of times, learning its every quirk, its every weakness, its every strength? Here's the twist that changes absolutely everything. Starship is fully reusable. Every previous spacecraft was basically a controlled explosion that you rode once, then threw into the ocean like expensive garbage. When you can only test a rocket design once, you're always flying blind. But when you can test the same rocket over and over, when you can land it, inspect it, refuel it, and fly it again, that's when you learn things that single-use rockets could never teach you. SpaceX has already landed boosters over 200 times. They know exactly how these engines behave under stress, how the metal flexes during flight, where cracks develop, how systems degrade, where failures actually happen versus where engineers think they'll happen. That data is worth more than any escape system ever built. It's like the difference between building a paper airplane with an ejection seat versus building a Boeing 747 that you know will fly safely for 30 years straight. Commercial aviation didn't become safe because of parachutes. It became safe because the same aircraft flew thousands of times, revealing every possible failure mode until flying became more routine than driving. But here's what keeps me awake at night about Musk's approach. He's betting human lives on a completely unproven philosophy. What happens when that first catastrophic failure occurs? When something goes wrong that all the testing never predicted? Because it will happen. In engineering, it always does. Traditional spacecraft lose maybe 3 to 7 people when things go catastrophically wrong. Starship is designed to carry 100 people to Mars. One single failure, and you're not looking at another Challenger or Columbia tragedy. You're looking at the deadliest space disaster in human history. And there's absolutely no way out. This isn't just an engineering decision. It's a philosophical statement about how much risk we're willing to accept and how many lives we're willing to gamble for the dream of becoming a multiplanetary species. The question that haunts every engineer working on this project: are we building the safest spacecraft ever or the most dangerous? The answer might determine the future of human space exploration forever. So here's the truth about Starship's missing escape system. Musk isn't just removing safety features. He's rewriting the entire rulebook of space travel. Traditional aerospace spent decades perfecting ways to escape from rockets. SpaceX is perfecting rockets you never need to escape from. But here's what this really means. We're witnessing the biggest gamble in human history. Either Musk creates the safest spacecraft ever built, or we're headed for the deadliest space disaster imaginable. The next few years will prove which vision of space safety is correct. NASA's escape system philosophy, or SpaceX's reliability-first approach. And honestly, the implications go way beyond just rockets. If Musk is right, it changes how we think about risk in every industry. If he's wrong, well, that's a conversation no one wants to have. What do you think? Is removing escape systems brilliant engineering or dangerous arrogance? Drop your thoughts below because this debate is just getting started. And if you want to dive deeper into SpaceX's most controversial decisions, you'll definitely want to see what we've uncovered about their Mars mission plans. Trust me, what they're hiding will blow your mind. Until next time, keep questioning everything.